All right, good morning, ladies. All right, how are you today?
Good.
All right, okay, let's open with prayer because we're going to need it today.
Yes. Very true.
Okay. Father God, we thank you for the beauty of your creation, and God, all that you give us and all that you call us to. God, we ask that you would today give us understanding, give us wisdom, and give us peace. And we thank you for it in Jesus' name. Amen. Okay, all right, so we've got a lot of things happening today, and I know that some of you are really anxious about your first test, and we're not going to do it right now, but we're going to get to that directly. All right, so what we're going to do, your assignments is going to be in looking at these three sections in chapter 2. Now, you're also going to be doing, to turn in, you're going to be doing the Unit 1 test. Right now, I haven't yet found out whether it's the Unit 1 test from the textbook or whether it's the Unit 1 test that I printed out. And I'm still trying to get that information. I'll have it before the end of class. All right, so we're going to do that. But today, we're going to have a short quiz over the sections of chapter 1. Okay, it's not that hard, it's not that long. Okay, and so that's what we're going to do. And then we're going to begin to review the chapter 1 skills. And I've got them up here, so you'll be able to take some notes, but you'll be able to see what we're working with. Okay? All right, any questions about the assignments from the past week? It's still pretty straightforward. It's still a lot of review, right?
Yes.
Okay, so you need paper for notes. Okay, you need to probably get your notes out because for sure when we get started, you're going to have some notes. All right, now, one of the things that educational theorists say is that you can take what students want and try to incorporate that into the lesson, and everybody is happier. Okay? So here's my question. Do you want to get the quiz out of the way now? Or do you want to wait and do a little bit of review, and then we'll stop after a while and do the quiz before we finish up? All right. I need a vote. All right. How many say quiz now? That's good. Okay. All right. How many say let's do some review first? Okay. All right. That's okay. That probably will be better. Okay. All right. So that's what we'll do then. We'll go to the review. So let me pull this down a little bit. Okay. Now. All right. So let me try to show you where we're going. This is not the review yet, but when you get into chapter 2, what you're going to be doing is finding x and y that make equations true, which is called substitution. If you have 2x equals y, and I say, what happens if x is 3? What's 2 times 3? 6. So you would have the point 3, 6 as the point where that would be plotted. All right? If I had 2 times x equals y, and I said y was 10, 2 times what is 10? 5. And so you would have 5, 10 as that particular point if it were graphed. All right, and so that's the majority of what's happening here. They're going to give you values for x and y, and you're going to use your algebra skills to be able to try to figure out what's the other letter, what's the other variable. Okay, and then graphing functions. All right, very important that you understand what the word domain means. What does domain mean? Say it loud. X values, the x values, right? So when you have a coordinate pair, the first number is the x, or the domain, and the second number is the range, or the y number, right? And so if I had a list of points, how would you find the domain? You would look at the x values in each point, and you'd write just the x values down. That would be the domain. Okay? And the same thing would be true for range. Okay, so now, the dependent, all right, we'll talk about this next week, but you'll begin to see this. Varies directly is an Algebra 2 skill. Some Algebra 1 books have that. If something varies directly, then here's what you have. Y equals some value, which we call slope, times x. So what happens if x goes up? Y will also go up. Because if you increase this value from 2 to 3, then this number is going to go up depending on what the k was. Right? And so if it varies directly, it means if x goes up, y goes up. If x goes down, y goes down. That's a direct variation. An indirect variation is a different equation. Okay? And then there's another vocabulary word, asymptote. Say that. Asymptote. An asymptote is a line that something approaches. Now, you've already had one type of asymptote, and that is infinity. What does infinity mean? Huh? It goes on forever and ever. Can you ever get there? No. You can approach it, but you can never get there. Well, an asymptote is a value that you approach but never touch. Okay? So, and when you get into the higher order equations and their graphs, a lot of times you have asymptotes. Okay? If you've already done conic sections where you have hyperbolas and ellipses, right? Some could even say circles, is that you're having asymptotes where the maximum value is reached but never exceeded. Okay, so those are that. Okay, so now the next thing that we're going to do is the chapter review. Okay, so if I can do this right, all right. Now this is on page 44 in your textbook. So if you want to open your books up to page 44 and just see what we're doing, you can do that. All right. Okay, so the first part in review question number 1 asks for examples of these types of numbers or number systems. Okay? So let's look at the first one, the small I, a rational number that's not an integer. Now that's two things. Okay? What's an integer?
A whole number.
It's a whole number, positive or negative. Right? Okay. Now what's a rational number? All right. You should see the word ratio. All right. What does ratio mean? Starts with F. It's a fraction, right? A ratio is a fraction. Could be written other ways, but for our purposes, a ratio is a fraction. So I want a number that can be expressed as a fraction, but it's not a whole number. Now, you have loads of choices. Okay? All right, and I chose 1, if I can get this to work. There we go. So, any fraction that's not a whole number will work. Okay, now, what is an irrational number? Okay, now, this is something that's important. A rational number was something that could be expressed as a fraction, and it could be a repeating decimal or it could be a terminating decimal. Right? An irrational number is basically a non-perfect root, like a square root or a cube root. Right? But it says that it is not positive. Now here's the difficulty, is that every even number, like a square root, can you take the square root of a negative number? The answer is yes, you can, but it's not real.
Right.
Okay? The square root of a negative number is not real because it's a number times itself, and you can't get a number times itself and end up with a negative. Right? So what you have to do to represent a negative, where'd it go? It keeps moving, I can't see it. I see my... There it is. Okay. Okay. If it is a non-perfect even number root with a negative sign in front of it, it'll be negative. All right, like let's take a perfect root. What is the square root of 25? It's 5, right? So in order to have a non-positive, I would have negative the square root of 25. The negative sign's on the outside. If it's an odd number, the negative can be in the inside. Because let's take the cube root of negative 8. Negative 2 times negative 2 is positive 4. And positive 4 times negative 2 is negative 8. So the cube root, when it's odd, of negative 8 is negative 3. So that gives you two different things, two different ways. If you have an even number root, like square root or fourth root, then the negative's on the outside. If you have an odd number root, then the negative can be on the inside or the outside. Okay? So, how would you do an irrational number then? Just make sure it's not a perfect root. Okay? So that takes care of both of those. Alright? Yeah. Alright, third one, let's see if I do this right. Alright, imaginary number.
Right.
What's imaginary? It's an even root of a negative number, or it's a digit followed by the lowercase I. Right? So, if you were going to write an imaginary number, you could write 3i. That's an imaginary number. I could also do square root of negative 11. Because the square root of negative 11 equals the square root of negative 11 times I. Okay, so either way. Okay. Now, transcendental number. Take this one.
Me too.
Alright, again. So let's try to make sense of it. Okay. Alright. If the number E is a specific value, right? It's not a rational number, it's an irrational number. So if you take the irrational number E and raise it to some power, you have a transcendental number. Pi, because pi is a specific value that is never ending and never repeating, is called a transcendental value. If you take any value as a base and you raise it to an irrational power, you're going to have a transcendental number. Sine, cosine, and tangent, the trig functions, are called transcendental. Right? And then, I don't know if you see this, but you notice that this is not an absolute value mark because it has a little thing on the top. Alright, this says round the digit up.
Oh, wow.
And what would happen if it was on the bottom? It'd be round the digit down. So it doesn't matter. Normally if you round it, if I said round this number, what would you round it to? 3, right? Because this is less than half.
Yes.
Right? But this symbol says make that number 4. If it was 3.99, make that number 4. Right. And if the things were on the bottom, then you would round this down to 3, but 3.99 would also go down to 3. Okay? Right? So, and again, that's a transcendental number. Okay? This is cool. This you get later on. This is used a lot in computer work too. Right? So, are you going to probably use that? No. You're going to use pi or a to the square. Yeah, but what I'm saying, these you might use now. Sine, cosine, and tangent, you should know at least something about that. Yeah. Because you had that with the Pythagorean theorem last year in Algebra 1. Yeah. So you might think of sine, cosine, and tangent as a transcendental, pi, and then this one. Those would be the ones I would expect that you could figure out. Okay? Now, a negative even number. Okay? I don't think I changed this. All right, you should be able to get that, right?
Yes.
Okay, a positive number that's not a digit. Now, what's a digit? 0 through 9.
Yeah.
So it's a digit is a whole number 0 through 9. So a positive number that's not that.
22.
22, 42, 62 hike. All right, any of those, or you could use, now because it's a positive number, you could also use any fractional value that's positive, any rational. Okay? Okay. Natural number, by definition, it's a counting number that's not 0. Okay? Now let me move this up. Alright, natural number, so now we're at a real number that's not a natural number. Now, because a natural number is a counting number, you're going to have 0 or any fraction that's not a whole number. That'll be real, but not natural. Natural starts at 1, not at 0. Whole numbers start at 0. Okay? Now, a real number that's neither positive or negative, 0 only. Okay? An irrational number that's not real. Alright, are irrational numbers real? Yes, so there's no answer to this one.
Right.
So that would be the null. That would be the null set, right? This one only has one answer, this one has no answer. Okay, so anything you put other than no answer is wrong on this one. Okay, alright? Now, does that make sense?
Yes.
Okay. Now, what I want to do, if I can, I got to get this thing out of the way because now it's hurting me.
Or close it this way. So
Well, I wanted to save it, so I'm going to just make it smaller
There you go.
and get it out of the way.
Try that.
I didn't get it right.
Right there. There we go.
All right, there we go. All right, now, okay, this is the next part. The next part says name the sets to which each of these belong. All right, what I've done is I've listed the words. Okay, and so the number 2, is the number 2 a digit?
Yes.
Yes. Is it a natural number?
Yes.
Is it a whole?
Yes.
Is it an integer?
Yes.
Is it a rational number? Yes. 4 over 8 is, no, 4 over 2, or 8 over 4 is, so yes. All right, is it irrational? No, so that's blank. Is it real?
Yes.
Imaginary? No. Complex number is an imaginary number plus a real number.
Okay.
Okay, so it's like 3 plus 4i would be a complex number. All right, transcendental? No. All right, and then is it negative? No. Okay, so -3. Okay, now, all right, let's see, that isn't right. What is going on here? Oh, I know, I'm sorry. -3 is not a digit. Why? Because it's not 0 through 9. Okay, is it natural? No, naturals are counting numbers.
Right.
Is it a whole number? No, because whole numbers are all positive.
Right.
Okay, but it is an integer and it is rational.
Right.
Right, so therefore it's not, it is real and it is negative. Okay. Now, square root of 3. Okay, it's not a whole number, not a counting number, so all those are out. It is irrational. Why is that? Yeah, there we go. It is irrational and it's real. Okay, is it imaginary? No. To make it imaginary, you have to go to this.
Right.
You have to have the square root with a negative on the inside. All right, and then 2.3 is 2 3/10. All right, it's rational. Because if we multiply, we'd have 23 over 10.
Right.
All right, so it's rational. All right, it's real, but it's none of the left. Okay?
Right.
And so a lot of times when you have this, you have to know what these definitions mean.
Right.
Okay? All right, that's example 2. Now, here is a part of something that you're going to need to write notes on, probably.
Okay.
All right, what is an axiom? An axiom is a property that's accepted as true without having to prove it. And I have never heard this word before. I've heard of lemming. This is people that just jump over the cliff. But a lemma is a property that's used to prove another property. Okay, so that must be a vocabulary word for proofs. All right? A corollary. Corollary is used often in math. It's a property that's easily proven from another property. Right? And so a lot of times you'll have a property and then the corollaries are other things that are true because that property is true. All right, this word you find a lot in geometry. Right? Remember your parallel lines?
Yes.
Right? If two lines are parallel, then alternating interior angles are congruent. Right? The corollary is if you have two alternating interior angles that are congruent, then you have parallel lines. Right? So it's a property that's easily proven from another property. And then a hypothesis is the if part of a statement. It's the given. That's the hypothesis. Now, is the given always true?
No.
We assume that it is, right? But if the given, after you have used lemmas that are true and not done any mistakes in your math, if you end up with a falsehood, then that means the hypothesis was not true to begin with. All right? And we use this a lot of times in algebra when you're doing systems of equations. And if you subtract one equation from the other and you get 0 equals 4, what values of x and y make 0 equal 4? The answer is no values, right? So therefore, those lines did not intersect to begin with, right? And that would be a false hypothesis that was proved because of your algebra. Okay, got those down? Ready to move on?
Yes.
Okay. All right, good. Now, okay, field axiom. And I talked with Artie this morning. All right, one of the things that I developed when I was teaching algebra and also pre-algebra was the term CATIE. All right, commutative, associative, distributive, identity, and inverse. Those are the field axioms. So, if an axiom is a CATIE property, it's a field axiom. Okay. Now, again, this is a term that's really, I've not heard that before, but I mean, I found out what the definition was, and that becomes it. So, if we look at this, the definition of subtraction is x subtract y is the same as x plus the opposite of y. All right, we've been using that quite a bit. Is it an axiom? No, it's not one of the major properties that we take as true without proof. Now, we know this is true, but it's not an axiom because it's not one of the CATIE properties. Okay? So, the multiplicative inverse property. Inverse is a CATIE property. So therefore, yes, it's an axiom, and yes, it's a field axiom. Okay? The trichotomy says that either it's equal, greater than, or less than some other number. Okay? So, is that an axiom? The answer is yes. We assume that to be true, but it's not a CATIE property. All right? Closure. Right? Closure means that if you do the operation, you end up with a unique real number. Addition is closed. Because if you take a real number and you add another real number, the result is still a real number. All right, so that's an axiom. Yes. Is it a field? Okay, now, I don't, all right, there's a reason for that. This is what the book says. Closure is true. It's a field axiom because if it's not closed, then we can't do anything with it.
Yeah.
All right, so that's the only exception to this rule. All right, additive identity.
Yes.
Okay, if you add a number to two things that were equal, they're still equal. So that's an axiom, and it's a field axiom. The multiplicative order. Now, order has to do with something greater than or less than. It works the same way as the commutative or the properties of equality, except that this is not an equal sign. So, if x is greater than y, what happens if we add the same number to both sides? It's still, the relationship is still, this side is greater than this side. Right? And the only time it changes is when you multiply by a negative number. Right? So the multiplicative order is not an axiom, right? Because it's order. The axioms have to do with things that are equal, right? And therefore it's not the other. Okay? And then the rest of this is working with a particular problem, and I'm not going to go over that with you right now. Okay? So that should help you on this short quiz. Now let me just give you what I would do if we were in a regular class. You have 5 problems and 1 extra credit problem. Okay. You have an order of operations. Shouldn't be any problem with being able to demonstrate you know order of operations. You have to multiply 2 binomials. What's a binomial? Something in parentheses, right? And what has to be in the parentheses is a letter with a variable and then a number, right? So give me an example of a binomial.
3x plus 5.
3x plus 5 or something like that. And multiplying those things is the FOIL method or the Floyd method that I use, right? That you did all throughout Algebra 1. All right, so that'll be on here. Now, then one of the things that's new is you're going to be given an absolute value problem where you have to come up with the solutions. And if you remember, what do you do with an absolute value problem? You take whatever the sign is and you do what? You put it on the other side and then make the number negative and then solve the dual situation. Alright? And then after that you're going to have another one with an inequality that you have to graph. Okay? Now, here's the thing I'll tell you about graphing. We did this one before. If you're going to graph something, draw a line and make 3 things. Alright? 1 for where 0 is, 1 for the larger number, and 1 for the smaller number. Okay? So let's say that, just for instance, let's say that I have 4 is greater than x, which is greater than 7. In this case, I have a 0 here, a 4 here, and a 7 there. You don't need to make all the little marks. We're smarter than that. Okay? Okay, we're smarter than that. All right? Okay, and then you have a fill in the blank question, and then you have a word problem. And I'll tell you this, the word problem is extra credit. Start with a picture. Draw the picture. Okay, that may help you. There's some specifics in there. In this particular situation that we're in, because I haven't been teaching the chapters, right, I don't know how much stress you've had on this word problem, but it's extra credit, so don't worry about it. Right, you should get at least 4 out of 5, right? I hope that you'll get 5 out of 5.
Yes.
Okay? All right, so you guys can do well, all right, and these guys are going to do well.
Good luck, Hannah.
Did I get it? That's not what I want. Here it is.